Hi guys. Maps. Where on earth are we, flat earthers? I recently saw a video on another flat earther who got his logic totally wrong and was saying, no, when we design our map or look at our map, we have to stick to the curvature calculation that ball earthers have given us. That makes absolutely no sense. I'm sorry, if a ball earther says the curvature is X, we can prove him wrong using his own formula, but that doesn't mean we need to stick to it to design our map. So just throw out that logic. We don't need to stick to any ball earther mathematics. And with that in mind, I want to discuss maps. Azimuthal equidistance projection map, sometimes it's known just as the AE map. I just want to warn all the flat earthers out there that this is actually a ball earth map. I know it seems weird because it looks flat, but don't fall for the bait, okay? And I just want to give a shout out to Rob Skiba. Thanks, Rob, for bringing this to our attention. Basically, he was saying that this equidistance means that each one of these rectangles in this round map here have equal distance, so equal length and width. So basically, if you take this round earth map and just unravel it, it'll end up just being a straight normal ball earth map. So don't fall for it, okay? This is just another close-up picture of it. And this is just another version of it. This is the map Rob Skiba was actually talking about when he looked into it, and he did some measurements actually, which was really good. So I encourage you to watch his video on it. So this is basically just a ball earthers map. Don't fall for it. When we design our map, we need to throw everything out the window and start from scratch, afresh. This is the one of the maps. I think I'm going to give it a shot and try and design a flat Earth map. And what I will use is I will use the true sizes of every country. So not the fake sizes as politics have dictated, as in black here, seen in black outline, but as in green. Green is like the true size of the countries. But I'm even going to go further than that. I'm going to say maybe the shape of these countries is also not right, also just given to us by ball earthers. So we need to be extremely open-minded here. We need to just throw out everything we know and somehow plot our own flat earth map, either using the sun or using, I don't know, aeroplane flights maybe, but except, that can be fudged a bit. Where do we start in designing our own map? Well, I think we should start at the very beginning, which is the Earth's circumference. And you might say, why start so far back? Well, I believe that's where we got it wrong, because if you haven't got the Earth's circumference right, you won't get the distance to the moon right, and if you haven't got the distance to the moon right, you won't get the distance to the sun right. And if you're a flat earther, you'll know that we believe in a close sun, a small sun. So we need to start at where I think we got it all wrong, and that is at the Earth's circumference. So here is a site I found. You can just type it in. I typed in, how do we calculate the circumference of the Earth? Click on any link. They both basically all say more or less the same thing, okay? They rely on ancient Greek philosophy, and it says this kind of thing. It's talks about this ancient Greek guy. That's his name. I've just highlighted there. Don't know how to pronounce it. But nonetheless, I'm not going to get into the whole story, but just to sum it up, there was a well in the area that he lived in that only had direct sunlight all the way to the bottom of the well once a year. He used that to realize when the sun was directly above his position. He then went north the following year at the same date, and he stuck a stick up and he looked at the shadow and he calculated the circumference of the Earth based on the angle between the shadow and the stick. Problem. First assumption, okay? The sun's parallel rays right? If you've watched any flat earth videos about the sun's rays, corpuscular rays in particular, go watch it. You'll discover that because we have a close sun, chances are that the rays are not parallel. So this is assuming a faraway sun, a faraway big sun. Okay, this is where the first error comes into it. Go research the story and you'll see it always comes down to parallel sun rays. Okay, and I think the city distance is between 500 and 800 miles or kilometers, I don't know, I forget, but quite a fair distance. Anyway, so I think that's where we got it all wrong, and I think we've got the circumference of the Earth wrong. And you might think, oh, come on, we've got all submarines and ships and navies circling the Earth and stuff like that. Surely they would know. Maybe they do know. Maybe they don't need to look out for it, so they're just not bothered for it. I'm not saying it's far wrong from maybe what this guy calculated it to be, but I am saying it is wrong. So anyway, so let's now jump to the distance to the moon. Okay, so the distance to the moon, this is from a site University Today. Okay, it says we start with a few knowns. Be careful when you hear the word knowns. Let's start with what we know. Okay, examine what he says next really carefully. If anyone says let's start with what we know, really, do we really know this? Is it really correct? Press in and do your research. Okay, so he says let's start with a few known. As we know, the ancient Greeks, okay, he talks about the moon traveling, etc., etc., etc. And then he says here, the diameter of the Earth is also known. Oh, really? What happens if you got it wrong? Okay, because he says, from these measurements, it was simple geometry that allowed another Greek guy to determine that the moon was, whatever, a distance, radar distance. So basically their whole formula for calculating the distance to the moon, okay, is based on the diameter of the Earth. So if that is wrong, then the distance to the moon is wrong, which means that the distance to the sun is wrong. So with the distance to the moon known, also University Today, the stage was set for another Greek astronomer to take a first stab at determining the Earth's distance from the sun, or to the sun. Okay, so if all three are wrong, then flat earthers, we have a chance to prove that their calculation of the distance to the sun is totally wrong and totally inaccurate. And you might say, well, if the diameter of the Earth is wrong or slightly out, does it make a big difference? Well, yes, it does. And I'll tell you why. Go watch this video. This video is a guy that tries to reproduce an experiment today using the equipment that they had back in Greek times. And he calculates the distance to the sun, and I think he is, I don't remember exactly now, about 200 miles or so out, okay? And he says the reason why he's out and he hasn't got the true distance to the sun is because of a pencil line. The thickness of his pencil line was inaccurate. So if the thickness of a pencil line equates to 200,000 miles, I ask you the slightest difference in the Earth's diameter, what will that give us? You have to be 100% accurate on these things if you're going to be calculating vast distances, guys. So I just want to give you a heads up. This is an excellent video. This guy's a ball earther, by the way. He's not a flat earther. But it's worth a watch to see how he does it. So we've got this circular reference. We know the diameter of the Earth. Therefore, we know the distance to the moon. Therefore, we know the distance to the sun. Well, how do we know the distance to the sun? Because we know the diameter of the Earth. circular reference here. We know the diameter of the Earth because of the parallel rays of the faraway sun. But hang on, we haven't proved the sun's far away yet. Okay, well, we can prove it because we know the distance to the moon. Oh, okay. I see how the circle goes. So, guys, I want to give you guys a shout out. We need to design our own map. We need to throw out everything we know of the current map, even land shapes. So, any suggestions? I'll be throwing something together, just initial concept, but I was thinking it would be quite good if we could get a database on all air flights. And I could write a program because I'm a programmer, and I could plot something out using averages of distances to places. But I wouldn't think that aeroplane flights would be as accurate as maybe sun positions or moon positions. And there are other flat earth videos on that. So guys, thanks for watching. Give me a thumbs up, subscribe below, and I haven't forgotten about the gyroscope. It's coming up next.